This is build up your understanding question number 8 from magnetic effect of current from the book Pathfinder. So let's see what is the question. Question is, there is a hollow rigid cylinder of radius r. So you can see this is the cylinder. Gravity is absent and uniform magnetic field B is everywhere parallel to the axis. So this is the magnetic field coming out of the plane. The cylinder is made up of an insulating material and is fixed by some external means. So cylinder is fixed. Very small ball of mass m and charge q is projected normally from point P. So this is point P. And from here, the ball is projected like this in this direction on the inner surface of the cylinder. Now, if the ball returns to point P after a certain number of elastic collisions with the cylinder, we have to find out range of velocity v of the projection of the ball, right? So let's see. So this is a cylinder. Cylinder is fixed. Magnetic field is out of the plane. And here particle is entering. So particle is entering here. Then you can use left hand rule and see that particle, this is velocity. Magnetic field is out. So force will be perpendicular. So that means center of the circle is here. So in this path, this will be the circle of particles trajectory. But it will start from here and it will only be able to come up to here. After that, it will have an elastic collision, right? So you will see this kind of diagram. So it comes here and then again elastically it collides and then comes here like this, collides elastically. So these all are similar type of circles. So it goes here, goes here, goes here. And then finally the condition is that it has to come back to the same point. Fine. So what I'm going to do, I'm going to find out the angle of deflection when it completes one part of the circle, right? Between two collisions, what angle it moves, right, along the axis. So for between this and this, whatever angle it is making, the same angle it keeps making, right? 2 theta, here also 2 theta, see in this diagram, here also 2 theta, here also 2 theta. And then finally condition is n times, suppose there are n number of collisions. So there's 1, 2, 3, and suppose like that there are n collisions. So n times 2 theta should be equal to 2 pi if there are n collisions, right? So after first collision, now what happens? It rotates by 2 theta, second collision 4 theta. After n collisions, it should rotate by 2 pi, right? So then only it end up to the same point. So I'm now going to find out theta. To find out theta, what I have to do now? So this is the circle, right? So one line we can draw. I'm assuming this point itself, this dot itself is the center of circle. And here, this is another tangent. So this is a tangent, just that now you have to see tan theta in this triangle. QPB in this triangle, see what is tan theta? Tan theta is equal to R. This is radius of the circle in which particle is moving, and this is capital R, right? That is what I've written. This is radius of the cylinder. So if you write this R we know is mv by qb. So if R is mv by qb, then tan theta becomes this. Tan theta is equal to mv by qbr. Fine. And now I'm going to substitute the value of theta here. So 10 times pi by n is equal to mv divided by qbr. So v is equal to this, right? So after that, you can then see this. I'm leaving for you to practice. You can then see what happens if n equal to 1, what will happen if n equal to 2, what will happen for n equal to 3, and so on. Right. So that's it. That was my analysis. If you have liked my analysis, please like this video and please subscribe this channel and share this channel with your friends also. Thank you very much. I'll see you in next video. All the best.